So we're going to continue on. We're on page 17. Page 17. And our job for today is to sketch. And this is not a good time to do table of values, okay? Because there has to be some ways to kind of figure it out. So, here we go. How do we do that? The very first thing that we gotta do is to see if we can factor the polynomial in the numerator and polynomial in the denominator. So why don't you go ahead and factor the numerator and or denominator. No, well, it's already like 2 times x squared. So, are you thinking of just putting a bracket around the x squared? Is that what you're thinking about?
No, put 2 on the outside and then x.
Oh, no, there's no need for that one. Yeah. Okay, so is that okay? So it's going to be 2 times x squared divided by x minus 5 times x plus 5. And of course, you already know this, but I'll just mention it. You figured out, hey, this is a difference of squares, perfect square, so we're going to end up with a binomial that's a conjugate. One's a plus, one's a minus. Okay, excellent. So from there, the very next thing that we're going to do is figure out the non-permissible values. Value or value. So what are the non-permissible values? X equals to 5, and the other one is x equals to negative 5. So we got 2 non-permissible values. Now, there are no common factors, so that means no whole. So no common factors. So that means no holes in this picture. And so that tells us the vertical asymptotes are x equals to positive 5 and x equals to negative 5. So those are the vertical asymptotes. Okay? So all of that came from the non-permissible values. Okay, so the next thing that we're going to do is we're going to do the horizontal asymptote. So how can we figure out the horizontal asymptote? Okay. So we see that the degree of the numerator, p of x, is equal to the degree of the denominator, q of x. And if this is happening, if this is true, then that tells us that the horizontal asymptote would be y equals to a over b. And what does a over b represent? That's right. Perfect wording. Leading coefficient of p of x is the a, and then the leading coefficient of the b for the q of x. So that's, what is that equal to? It's going to be 2 over 1. So I'll just go 2. Is that okay? Great. So we got 3 asymptotes. 2 verticals and 1 horizontal. Awesome. Okay. So far so good. Now, what we're going to do is we're going to figure out the x-intercept and y-intercept. So let's do the y-intercept first. It doesn't really matter. So if we want to do the y-intercept, what do we need to do? Set the x value equal to 0. Okay, so let's do that. What would happen when we set the x equal to 0? Y is equals to 2 times 0 squared over 0 squared minus 25. And that's going to give us y equals to, the numerator is 2 times 0 squared is going to be 0. divided by negative 25, so it's going to be 0. Okay, so we know that our graph will cross the y-axis at 0. Okay, so what's our coordinate there? 0 will cross the origin. Now what about the x-intercept? How can we figure out the x-intercept? This time we're going to set y equals to 0. So if y is equals to 0, let's just do that. 0 equals to 2x squared divided by x squared minus 25. Okay. What do you think we should do after? Cross multiplication. Okay. Now I want to mention this ahead of time because we're going to see it all the time. So when we look at if the x-intercept is basically focusing on the numerator. Okay, let me repeat that again. The x-intercept will be based on the values that will make the whole thing 0. So when we cross multiply, it doesn't matter what the denominator is. It's crosses multiplied with 0, it's going to be 0. Right? So it's going to be 0 equals to 2x squared. Okay, so what is that equal to? Divide by 2, that cancels, and then you're going to get 0 equals to x squared, and then square root it's going to be 0. Okay, so that means our x-intercept is 0. Yeah. So this one is 0, 0, and then of course this is also 0, 0. Okay, so now that we've gathered all of the puzzle pieces together, we're gonna create a picture, right? Beautiful picture. If you need a ruler, I have a few extra. We're gonna need it so that we can draw a really, really nice graph.
Do you have a small one?
There's a small one right here. Do you want that small
Yeah,
one?
I'll borrow that one.
Okay. So they're over here. Help yourself. I'll put it there. Oops. Okay. So what do we have? Vertical asymptote at 5 and negative 5. So this is 1, 2, 3, 4, 5. Okay, so that's going to be our vertical asymptote. And vertical asymptote is drawn dashed line, so that, and then arrow, arrow. Okay? So that's the positive 5, and then I'm gonna do the negative 5. Let's do the negative 5. Sometimes on the test and on the exam, we have to show where the asymptotes are and label them. So we're gonna say, hey, this is my x equals to negative 5 asymptote, and then this is my x equals to positive 5 asymptote. Okay?
Do they have to have arrows too?
Yes, yeah, because asymptote keeps going on both ends, continuously going up and down for vertical. Yeah. Okay, good. So I did the arrow also at the bottom. So, okay. Now we're going to do the horizontal asymptote, and we said the horizontal asymptote is y equals to 2. Okay, so y is equals to 2 for horizontal. So it's this one. Okay, so that's my y equals to 2. And I'm also gonna put an arrow on each end. And I'm gonna identify that as my asymptote, so it's y equals to positive 2. Okay. So we have this asymptotes, and what else do we need to do? We figured out the x-intercept and y-intercept. So x-intercept and y-intercept is 0, 0. Okay, good. So our graph kind of looks like that with just 1 point. So now what we're going to do is we're going to see what happens to the left of the asymptote, between the two horizontal asymptote, and then the other side of the asymptote. What's happening? This is where you could rationalize it, think about how it's going to behave, okay? Or, you know, sometimes it's, for me, I like it when the numbers is in front of me, okay, to see it. So, I'm out of room, so I'm going to do this. Okay, so what I'm going to do is I'm going to see where my graph is to the left of this asymptote, okay? So, I'm going to pick something on the left of -5, so I'm going to pick -6, okay? Make it easy. So if, okay, if x is -6, if x is -6, what is the y value? So y is equals to 2 times -6 squared over -6 squared minus 25. So that's going to give us 36, it's positive 72, over 36 minus 25. That's going to be 36. 36 minus 25. 11. Yeah, 11. Okay, so that means the point is at -6, 72 over 11. Well, what's 72 over 11? So this is going to be approximately, because if it's 77 over 11, that's going to be 7. It's going to be 6 point something, right? 6 point something. So 72 divided by 11 is approximately 6.54. Okay? So that tells us that if this is to the -6, we're going to get a -6.54. So -6 and 6.54 would be right here. Okay. It's going to be positive. And then let's see if this makes sense. If we have a negative value and then you square it, that's going to give us a positive. And then you have this one here, you have a negative value and you square it, that's going to give us a positive, right? So that's going to be, it's going to give us a positive value overall. Positive divided by positive would be a positive. Now what's happening in here is that it's going to be it's going to be moving this way. Okay, because this is an asymptote, it will have to bend like that. Okay, is that good? Yeah. Now, if you try another one, if you try -7, okay, try -7. Okay, what would be -7? That's going to be 2 times -7 over -7 squared minus 25. That's going to give you 49/98, positive 98, and then 49 minus 25 would be 24. So 98 divided by 24 is going to be approximately 4, right? So approximately, oh, wow, look at that one. Weird. Okay. So as you can see here, what's happening is that we get 6, and then now it's down to 4. So it's gonna decrease as it approaches the horizontal asymptote. Okay? Good? So far so good? Okay. Now, over here, between these -5 and +5 vertical asymptote, we already have some kind of a clue what's happening in here. It's not going to be above, it's going to be below, because we already have this y-intercept / x-intercept. So let's just kind of pick any value to the left of that and then to the right of that and then graph it, okay? So of course we're going to pick a nice number. We're going to pick a -1. So if x is -1, okay, what is the y value? 2 times -1 squared over -1 squared minus 25. So that's going to give us, the numerator is going to be always positive. Do you agree? Yeah? Everybody agrees on that one? The numerator will always be a positive because 2 times something squared. If you square something, it's going to be positive. This is going to be 2. And then this time, the denominator becomes negative, right? It's going to be -24. Yes? Yeah? And then that's 2 divided by 24 is approximately -0.08. So at -1, it's going to be 0.08, really, really tiny, right there. Yeah? Okay, let's pick the positive one. Why don't you go ahead and figure out the y value when x is +1. It's the same. Yeah, it's the same, right? It's the same. -0.08. So it's going to be like that. Pretty close to the x-axis. So what's happening in here? It's going to keep going down this way. Okay, it's not going to cross the asymptote, but it's going to approach it. And this is a sketch. Yeah, it's best to do this with pencil so that if you need to erase, it's easy, it's not messy. Okay, good. Now, we figured out this side, we figured out the middle. Any guesses what the right side is gonna be? It's gonna be like this one? Okay. So, yeah, if we pick a number, what did we say? If this is 5, let's pick 6. Okay, what would happen if x is 6? It's going to give us a positive. It's going to be the same thing as the other one. is gonna be, the other one, 7 is. Oh, having a hard time here. It's kind of looking like that. Okay, so it approaches both the vertical asymptote here and then the horizontal asymptote there. Okay, is that good? Yeah. What do you think? It's okay? Let's try one more. Okay, let's see this one. Huh? How do we get this one here? Oh, yeah. So this one here, we had to figure out the x-intercept and y-intercept. So here, to figure out the y-intercept, we're going to set x equals to 0. So we put 0 wherever we found x, and then you go 2 times 0 squared is 0, divided by negative 25. So 0 divided by negative 25 would be 0. Okay, so that's the y-intercept at 0, 0. And then when we did the x-intercept, it's 1. Oh, maybe I'm not seeing what you're seeing. Show me again. Come show me. I'm not sure. Oh, how did I get that? Those 2 points. Oh, okay, sorry. It's this one. Sorry, I thought you said the 0. So I picked the number this way. So I picked if x is negative 1. So if x is negative 1, so if x is negative 1, and then I had to figure out the y. So substituting negative 1 to the x. So y is equals to 2 times, yeah, this is the function. So we substitute negative 1 for the x, and then we substituted negative 1 for this x, and then worked it out. So it becomes 2 times 1 squared would be 2, and then, sorry, it's negative 1. Negative 1 squared is going to be positive 1. Positive 1 minus 25 is minus 24. And then 2 divided by negative 24 is going to be 0.08333. And then we pick the x. If x is 1, so we substituted the 1. I didn't show my work here. So 2 times 1 squared over 1 squared minus 25. So 2 times 1 squared is 2. 1 squared minus 25 is negative 24. So it's also negative 0.83333.
So because the intercepts are both 0, is the only graph you have to sketch in this one the bottom one of the 3? Like are the other 2 relevant?
Come again? So,
Because we figured out originally our intercepts are 0, right?
yeah, we figured out that.
So is that graph that you just had your pen on the only graph you want here, or do you need the other 2? Because to me the other 2 are irrelevant. They have nothing to do with the intercepts. They are part of the equation when you figured it out, but
Okay.
you didn't ask for that part. You said sketch the graph.
So what you're saying is like, since we figured this out, we could just go like this.
No.
Oh, okay.
I'm saying once you figured out that bottom part, do you need to do the top 2 graph parts as well?
Oh, this too.
Yeah.
Oh, yeah, that's still part of it. Yeah, so the behavior of the graph to the left of this asymptote is right here, and then the behavior of the function, the behavior of the whole function after this asymptote, vertical asymptote at x equals to 5 would be something like this. Yeah, so this is the whole graph. Yeah. Not just the bottom, but the whole thing. Yeah.
So it's all showing n behaviors technically. Now what if you wanted to find, we thought we used y and we put a number to x, but if you wanted to find the x values instead of the y values, would you still figure out the same exact graph if you just punched in numbers for y?
So given the y and then find out the x? Oh, you could, yeah. That's probably a lot more extra work, yeah.
Yeah, a lot harder.
A lot harder, because you're working kind of backwards.
But you can technically do it, right?
Yeah.
Yeah?
Yeah.
Okay.
Honestly, I probably wouldn't do that.
No, I know.
So, use the x to find out the y. Anything else? Yep.
Yeah, I don't know what's called this one, but how do I know they come in? Now this one we have quadrant. I don't know, on parabola, right?
Oh, okay.
And that.
So this one here is actually, okay. So now this one kind of looks like a parabola, but it's really not a parabola. Okay. So parabola happens when you have a quadratic function. So this one here is a rational function. Yeah.
My question is, how do I know? Like now we have, I don't know what's called that one, and these two.
Yeah.
How do I know if they come in like 2, 3, 1?
How do I know
If
when?
they come in 1 or 2 or 3, how do I know?
Oh, how do I know if there's like
Just
how many
one.
pieces?
Yeah,
Well, it depends on your asymptote. Yeah, depends on your asymptote. So the question is like, how do I know how many pieces are all in this graph? Depending on your asymptote. Yeah, you're all good. Okay. Yeah. Okay. Yeah. Good. Well, that's just a that's example number 2. Okay, where there's lots of things going on. So let's take a look at example 3. Maybe if this is still kind of like, oh, I don't know, I'm not quite there yet. Let's see this one. Okay, the very first thing that we're going to do is factoring. Okay, so let's go ahead and factor this thing. Yes. Yeah. Is everybody?
What if p of x, the degree of p of x is bigger than the degree of p of x by more than 1?
That's going to be beyond the scope of our stuff. For our course purposes, it's still possible, right? You could have,
Would it be a leap though?
we can take a look at that at the later time when we, yeah. Okay, I didn't really talk about factoring, but I think absolutely sure that you're okay with factoring, right? I've seen you factor before. I think no problem there. Okay, so what's a non-permissible value? X equals 2? -1/2. Is everybody okay with this? And please say no if it's no. I'm not going to be like, what? Okay, how did we get that one? So we're going to set this equal to 0. So 2x plus 1 equals to 0. Bring this to the other side. So 2x equals to -1. And then divide by 2. So solving for x, really. So -1/2. Yeah? Okay. So what about the other one? What's the x equals to +3. Very good. So these are the non-permissible value. So is there a common factor? Yeah.
Yeah, I was just gonna say, if there's a common factor and you cross it out, you still have to write the -1/2, because technically it's taken out by the vertical asymptote.
Oh, that would become a whole.
Yeah,
Yeah.
So would the NPD still have to be made up?
Yeah, yeah, yeah.
I would get maybe 1/2
Because this is the one of the factors, right? And then you try to solve for x.
Okay.
Yeah, you're good? Okay. Is everybody good with that? We've been so, lucky lately, because most of our factors are like x plus 3, x minus 1, but then this one here is like 2x plus 1. Okay, so that's good. Like, we want to make sure that we cover everything. So x equals to -1/2, and then the other one's x
Show me the calculation
plus
for
3.
the half again.
Yeah, for sure. So bring the 1 to the other side of the equation. That makes it the -1. So 2x equals to -1. And then 2 times x equals to that, to divide by 2. Yeah. Is that good?
Yep.
Cleared it up. Okay, so since there is a common factor, okay, there's going to be a hole. Okay, so there's a hole at, which one is that? This is the one that cancels, at x equals to -1/2. So let's cancel that out and figure out the exact location of the hole. So if x is equals to -1/2, y would be, well, this is canceled, this is canceled, it's going to be 1 over x minus 3, right? So y equals to 1 over -1/2 minus 3. Okay, so that becomes y equals to 1 over -3 halves. So that's -7 halves. So y is equals to, are you okay so far? No? Okay. Okay. If there's at some point that I'm kind of like, oh, I don't know what you're doing there. How did that get there? Let me know right away. So I was actually trying to save space. That's why I'm kind of skipping steps. Is everybody okay at this part here? Since there's a common factor, right? We've canceled a common factor, then there's a hole at -1/2. Yes?
1/2 because the coefficient is still 1.
Yeah.
Yeah.
Yeah. So when we can, okay, so after that, I have to go like this. Y equals to 2x plus 1. 2x plus 1 times x minus 3. So this is a one factor that gets canceled. So if we cancel that, what's left in the numerator is just 1, right? So it becomes y equals to 1 over x minus 3. Yes? Okay. Now we know that x is -1/2, right? -1/2. So y is equals to 1 over -1/2 minus 3.
I have a question.
Yeah.
What if I don't put the 1, if I just say y equals to x minus 3? What do you do that?
Come back. So what if you did not erase this one?
I erased, but I didn't put the 1 at the bottom. I just put y is equals to x minus 3.
Oh yeah, it's not going to be correct because that just gives us the, yeah. Okay, can I show you something? Okay, I'll show you something. Why we need to kind of clarify this one in the numerator. Okay, set this aside. Don't think about it right now. What if I go simplify this? Okay. Okay, so this is what you did. 3 and 5 has a common factor of 3. So and then you go, oh, this is gonna be 1, and then this is 5. Yes? Okay. We didn't say 5. We said it's 1/5, right? So there's a difference when there's a 3 in the top and the denominator. So that's gonna, even though there's a common factor of 3 that we canceled, right? There's still a 1 there. Yeah? Yes? Clear. Okay, so, oh, what did I do now? Oh, this is where I am. Yeah, feel free to ask, because if you don't ask, you're gonna go home and say, oh, what happened here again? So this now becomes a complex fraction, because part of the fraction is a fraction, complex fraction. So how do we do that? 1 over, when we subtract fractions or combine fractions, they have to have the same denominator, correct? Okay, so denominator is 2. So that's gonna be, oh, this is 1, so times 2 times 2. So that becomes -1/2 minus 6 halves. Yes? Yes? Okay. So it's gonna be 1 over -1/2 minus 6 halves, that's going to be -7 halves. And then how do we deal with this complex fraction? It's 1 divided by -7 halves.
2 is 1.
It's going to be, multiply the reciprocal, it's going to be -2 over 7. Multiply the reciprocal. So this becomes 1. And then multiplying the reciprocal of the denominators, it's going to be -2 over 7. So it's going to be 1 times -2 is -2 over 7. So the whole is at negative. X, oops, I'll just write down the coordinate there. The whole is exactly at -1/2, comma, -2 over 7. Okay? And where's -2 over 7? 2 divided by 7 is about 0.285. Okay? So, okay, what have we done so far? Not a lot. We've factored, we figured out the non-permissible value, we found out that there's a common factor, so that means there's a whole, and we figured out the whole. What else? Any vertical asymptote?
Still in here, why you flip the 7 over 2?
Okay. I'll finish this one and then I'll talk about that one in a second. Okay, so there's a whole here, and then this one would be the vertical asymptote. It's going to be x equals to 3. Okay, now what about horizontal asymptote? The degree of p of x is less than the degree of q of x. Okay, when that happens, your horizontal asymptote would be y equals to 0, because the denominator gets so much bigger faster compared to the numerator that gets closer and closer to 0. Okay, what else do we have? So we figured out the whole, the vertical asymptote, the horizontal asymptote. The next thing that we're going to do, okay, is the intercept. Okay, can I squeeze in the intercept here? Yeah, I'll try here. So now we're going to figure out the x-intercept. How do we figure out the x-intercept? Set y equals to 0. So that becomes 0 equals to 2x plus 1 divided by 2x squared minus 5x minus 3. So when we cross multiply, the x-intercept will be just the numerator. That's going to help us. The numerator is going to figure out the x-intercept. So it becomes, cross multiply that. So 0 equals to 2x plus 1. Bring that to the other side. So x equals to negative 1/2. So it's going to cross the x-axis at negative 1/2. What about the y-intercept? To figure out the y-intercept, we're going to set x equals to 0. Okay. So what's that equal to? 1/3, right? Okay. Yeah, negative 1/3. So if we set x equals to 0, I'll just put it in here. So 2 times 0 is 0 plus 1, 1. 2 times 0 squared, 0 minus 5 times 0, 0 minus 3. So minus 3. So the y-intercept is at negative 1/3. Okay, now we got our asymptotes, whole, x-intercept, and y-intercept. Yeah. Oh, vertical asymptote? Because of the non-permissible value. These two cancels, there's a common factor, so there's a hole here, and then, but this one will give us a vertical. Yes? Okay, anything else before we graph? We're good? Okay, so let's do that. Vertical asymptote at 3. Okay, so vertical asymptote at 3. So that's going to be x equals to 3. There's a hole at negative 1/2, negative 2/7. So negative 1/2, negative 2/7. Negative 2/7 is 0.28. So there's going to be some kind of a hole here. So put a hole there in our graph. Horizontal asymptote is y equals to 0, so let's do that. I haven't done the x-intercept yet. Now, take a look at this one here. Let's see. You're thinking the x-intercept is negative 1/2. So negative 1/2 for x-intercept would be over here. But then when we take a look at this one over here, they contradict. So really, this x-intercept is not supposed to be there. Okay? Okay. Good. Okay. When we calculated the x-intercept, it's negative 1/2. Yes? But then you look at this one, oh, negative 1/2 is not allowed. So that means this x-intercept is not the real x-intercept. Okay? Good. So that's not going to happen. Now, what about the y-intercept? Y-intercept is negative 1/3. Oh, where's negative 1/3? That's going to be right there. Okay. So what's happening now? how many pieces do we have? I have a point in here, so I'm thinking that the graph will be in this area, and then on this side of the is gonna be over here. Okay, so yeah. Come again. Yeah. That's a hole, there's a hole here at -1/2 and negative 2/7. So the graph, okay, so let's just pick a number let's pick a number 2. What would happen when we say x is equals to 2? What would happen when x equals to 2? What is the y value? Okay. Why don't you calculate that one? If x equals to 2, what is the y? That's going to be -10, -3, okay, -13, 5, -5 is -1. So there's a point at 2, -1. So there's going to be a point at 2, -1 right here. Okay, so our graph would approach this way.
It goes through the hole, right? Like it doesn't, it's not a permissible value, it goes through it.
Yeah. You still have to draw that one. So make sure, I'm very picky. I know I shouldn't be really teaching for the provincial exam, but this is what they're looking for. Arrows, there's a hole, and then this gets closer and closer, but not touching it. Okay?
You just randomly pick the 2 or?
Yeah, so because x equals to 3 here, we have to look at what's happening to the left side of that asymptote and then to the right side of that asymptote. So if x is 3, I just picked 1 to the left of the asymptote. And let's pick the one on the right side of asymptote. What would that give us? So if x is equals to 4, what would happen? Did you find a better way of calculating the y value? Yeah. Because y is equals to, there's a common factor, right? So it's going to be 1 over x minus 3. We've canceled a common factor. So y is equals to 1 over 4 minus 3. So y is equals to 1. So 4, 1. So 4, 1. So it's going to be just what we thought. It's going to be above the horizontal asymptote. It's going to be going like this. Oops. There you go. Okay, so there's a hole, and then this part, okay, you were asking about how many parts are there, okay? So one part here, and then the other part here, and they both have to be there. Okay, I'm gonna pause right here. When we return, we're gonna do the last two.